Section 7.6, Ratio and Proportion. A ratio is a comparison of two numbers expressed as a quotient. A ratio with different units is called a rate. So let's write the following ratios as quotients. A ratio of 15 women to 12 men. 15 women to 12 men. Let's simplify that. Divide numerator and denominator by 3. And we get 5 to 4. 5 women for every 4 men. A ratio or rate of 155 miles to 3 hours. 155 miles to 3 hours, that's a rate. Miles per hour. Can you simplify that? What is 155 divided by 3? 51.67 miles per hour. A proportion is a statement that two ratios, A over B and C over D, are equal, written as A over B equals C over D. But of course the denominators cannot be equal to 0. One way to solve a proportion is by the cross product method. So if A over B equals C over D, then A times D equals B times C. You can cross multiply. So our first problem, 5 over 4 equals x over 12. We're going to cross multiply. 5 times 12 equals 4 times x. 5 times 12 is 60 equals 4x. We divide both sides by 4 and we get 15 equals x. And that's our solution. Of course, our problems could be a little more complicated if we have x minus 2 over 3 equals x over 2. Let's cross multiply. So we have 2 times x minus 2 equals 3x. 2x minus 4 equals 3x. Let's subtract 2x from both sides and we get minus 4 equals x. And that's our solution. You can put it back in the original problem and verify that it's a solution. Check your answer. Cross multiply for example C. 5 times 2x plus 3 equals 4x. 10x plus 15 equals 4x. Let's subtract 10x from both sides. And we get minus 6x equals 15. Divide by negative 6. And you get 5 halves, that's negative, equals x. That's our solution. You can verify that it's our solution by putting it back in the original problem. Let's solve this next problem. We'll cross multiply. 5 times 2 is 10. X times x plus 3. Ooh, this problem's a little different. 10 equals x squared plus 3x. How do we solve a problem like this? Whenever we have x squared and x, we need to get equals 0. So if we subtract 10 from both sides, we get x squared plus 3x minus 10. 0 equals, let's factor that, minus 10. We need a 5 and a 2. Let's make it plus 5 minus 2, and that will give us our middle term of plus 3x. So we have this factored equal to 0, so we know to set each factor equal to 0. That gives us x equals -5, x equals 2. We have two solutions. Either one of these numbers, when substituted into the original equation, will make a true statement. Try it. You'll see that both answers are good solutions to this problem. So what can you do with these proportions? Well, if you find out that a 120-pound person should eat a minimum of 44 grams of protein each day, how much protein should a 180-pound person eat each day? We can solve this with proportions. So 120 pounds, we're putting the pounds in the numerator, should eat 44 grams of protein. So we'll put our grams in the denominator. So that's our first ratio. 120 is to 44 as 180 pounds, put the pounds in the numerator, is to how many grams? We don't know. Let's put an X there. Pounds in the numerator, grams in the denominator. We set up our proportion. We can solve this. We'll multiply 180 times 44. That's 7,920. And that should equal 120 times x. We want to solve for x. Let's divide by 120. What is 7,920 divided by 120? That gives us 66. X is in the denominator, so it's grams of protein. A 180-pound person should eat 66 grams of protein. That's our solution. Let's go back to the original problem and think about that. 120 pounds eats 44 grams. 180 pounds eats 66 grams. 180 pounds weighs half again as much as the original person, 60 pounds more than a 120-pound person. How much protein do they eat? Half again as much. Half of 44 is 22, so 44 plus 22, 66 grams of protein. It just makes sense. I like it when the answer seems logical. Similar triangles. If two triangles are similar, they have the same shape. That is, their corresponding angles have the same measure and their corresponding sides are proportional. So in this figure 1, triangle ABC is similar to triangle DEF. So AB over DE equals BC over EF equals AC over DF. Now notice what they're doing here. Triangle ABC is similar to DEF. So ABC, the first two letters are A and B. DEF, the first two letters are D and E. So they put AB over DE. The last two letters in the first triangle are B and C. The last two letters in the second triangle are E and F. You put them over each other in the proportion. And finally, AC is the first and the last letter. DF is the first and the last letter. You have to make sure that you go through the angles and the sides of the triangle in the same way. So looking at the sides of the triangle here, we have 9 over x equals 14 over 6. We can solve that. 9 times 6 is 54. That equals 14x. Divide both sides by 14, and you get x equals 3 6/7. Our second proportion, y is to 7, as 14 is to 6, gives us 6y equals 7 times 14, 98. Divide both sides by 6. And we get y equals 16 1/3. And that's our y value. So let's set up our proportions very carefully, making sure that we go through the letters in the same order. So when you look at the triangles originally on the left-hand side here, it's kind of hard to see what the relationship is. Notice that it's x, y, z, x, y, z. So if we, and it's p, q, r, so p, q, r. So if we put our triangles, kind of orient them, draw one inside the other, so that they're oriented the same way, that might help us get our proportions right. So let's set up a proportion. We have x, y, z, and p, q, r. So our proportions are xy is to pq as yz is to qr as xz is to PR. Did we do that right? All right, once we have that, let's just go ahead and put all the values in that we know. X to Y, that distance is 9. P to Q is 2. Y to Z is M. Q to R is 3. X to Z is 11. And P to R is N. All right, so we have all of our ratios. Now let's see if we can figure out what to do with them. If you take just these first two, you get 9/2 equals m over n, or m over 3. So we can solve that to m equals 27. Divide by 2. M equals 13 1/2. So that's fine. Now, we need to solve for n, and we know that we have a fraction, or a ratio of 11 over n, but we need to set that equal to something. I know what m is now, so I'm sort of tempted to use this, but I'd rather go back and use what I started with. I had 9/2. I like that one better. Let's go back and use the original ratio where we know both the numerator and the denominator. And that gives us our proportion that we can solve. 9/2 is to 11 over n. 9 is to 2 as 11 is to n. So let's cross multiply. 22 equals 9n. Divide by 9. N equals 2 4/9. And that's our n value. So we set up our proportion with 3 different fractions. We chose the first 2 to solve for m, and then we chose the first one and the last one to solve for n. So example 5, how tall is a flagpole that casts a 45-foot shadow at the same time that a 5.5-foot woman cast a 10-foot shadow. Well, we've got a drawing here. We've got the flagpole, and the woman is right here. So, the flagpole cast a 45-foot shadow. Let's think about that as a right triangle. And we have another right triangle of the woman who is 5'5", 5.5 feet, and her shadow is 10 feet. These triangles should, because they're both being made, the shadow is being made by the sun both times, these triangles should be similar triangles because they're both being caused by the sun. So what we're going to do is set up a proportion. We have the woman is 5.5 feet. The woman is to her shadow. As the flagpole, that's what we want to know. Let's call that F. As the flagpole is to its shadow, 45 feet. So the woman is to her shadow as the flagpole is to its shadow. That's our proportion. Let's cross multiply and solve. So we have 10F equals 5.5 times 45. $247.5. Let's divide by 10. So the flagpole must be 24.75 feet. Let's think about that for a moment. She's 5'5" and has a 10-foot shadow. The flagpole has a 45-foot shadow. And we said that it is 24.75 feet. Now, does that make sense? The flagpole's shadow is 4.5 times bigger than her shadow. So, what is the 24.75 divided by 5.5? 4.5. So the flagpole is 4.5 times taller than the woman is. It makes sense. It's proportional. A zebra can run 15 miles per hour faster than an elephant. A zebra can run 8 miles in the same time an elephant can run 5 miles. Find the speed of the zebra. We have 15 miles per hour faster than the elephant. So we have the zebra and we have the elephant. So the zebra can run, the rate at which the zebra runs is 15 miles per hour faster than the elephant. So if the elephant's going E, the zebra must be going E plus 15. A zebra can run 8 miles, that's distance. A zebra can run 8 miles in the same time an elephant can run 5 miles. So, I don't know, let's just make it proportions. There are many different ways that you can do this. It says find the speed of the zebra. Well, we've got it set up where we're going to find the speed of the elephant. But then we can figure out what the speed of the zebra is. So, there are different ways to do this. You could just say that the zebra goes in the numerator and the elephant goes in the denominator. You can have E plus 15 over E, zebra over elephant, zebra over elephant. That's one way to work it. Let's go ahead and solve that. Cross multiply. So we have 5 times E plus 15 equals 8E. 5E plus 75 equals 8E. Subtract 5E from both sides. 75 equals 3e, so e equals 25. So the elephant is running at 25 miles an hour. How fast is the zebra running? E plus 15. That's 25 plus 15. 40 miles an hour. Now, there's another way we could have set this problem up. I want to talk about that for a minute. You could have thought, what is the relationship between distance, or rate, and distance? We know that distance is rate times time, and we know that distance divided by rate equals time. And it says that they're running in the same amount of time. So we could have set this up as the distance that the zebra covers, 8, over his rate, which is e plus 15, is the distance that the elephant covers, 5 miles, over his speed, which is e. The times are equal. I leave it to you to show that this gives you the exact same answer, because 5 times e plus 15 equals 8e is exactly what we got. So we could have set up this proportion either way. Same thing. There are 30 students in a class. If 5 more males are added to the class, then the ratio of females to males would be 2 to 3. So our ratio is females to males. And we're going to make that 2 to 3. But that's after we add 5 more males. So let's think about that. There were 30 students in the class. Well, originally, let's come over here to the side. Originally, there were, let's say, m males in the class. How many females? Well, let's see. Let's take our 30 and subtract m. That's how many females were originally in the class. But now we're going to add 5 males to the class. The number of females will not change, so it's still 30 minus m, but the number of males will change. We will add 5 more males to the class. And that's our answer, or that's our equation, that's our proportion. Let's solve that. 2 times m plus 5 equals 3 times 30 minus m. 2m plus 10 equals 90 minus 3m. Let's add 3m to both sides. We get 5m. Let's subtract 10 from both sides, and we get 80. Divide by 5. M equals 16. How many males are in the class? 16. How many females? Doesn't ask us to solve for that, but let's think about it. How many females? 14. And then after you add the 5 males, you still have 14 females, but now you would have 21 males, which gives you a ratio of 2 to 3. That's all for this section.